all I mean to say is that I'm going to check that resistance again. So we got, I see I'm getting about 7 ohms, which is not ideal considering directly from the pin on the connector, I was getting much lower resistance. So the thing what I want to do is I'm just gonna wiggle this connector while I look at that resistance, and lo and behold, it is going up and down. I don't like that. All right, so I just wiggled that connector a little bit and it went down to 1.2 ohms. Now I haven't used any contact cleaner on those connections yet. So you see there's a good connection, 1 ohm. Actually, there you go. So what's probably happening there is by just wiggling this a little bit, I'm probably scratching those two connectors, those two contacts together, and removing some oxidation that's on there, and it's improving. But before I actually do this under power, I'm going to definitely want to use a anti-oxidizing contact cleaner on those connections. Now I've hooked my alligator clip up to the what's left of the red cable, the red battery cable, and I'm going to do the same check I just did, only I'm going to look for the first stop for the main power coming in, which is going to be really right here, this side of the solenoid. And if I go on there, you can see low resistance. That's good. And I just happen to notice that, hey, look at that. That's loose. I never tightened that. So there's another thing on the to-do list that I didn't get around to doing. So that was fortuitous that I just spotted that now. So I'll have to make sure I tighten that. That's probably why I didn't have this rubber boot all the way on, but still, the memory. Now I also know that that big 12 volt pin, positive pin, is also tied to one of the other pins, or actually one of the other wires here. And it's tied to this thick red wire right here, which makes 2 stops. One right over here on the rectifier, okay? And that's common to, so that's right here. So that's why I'm getting 1 ohm there. And that's common to this pin here on the electronic switch box. And the reason why that is always attached to the battery is because when the motor's running, this is the circuit that actually is responsible for keeping the 12 volt battery charged. So that's always going to have 12 volts on it when that plug is plugged in and the battery is connected. So the next thing I'm going to look for is this other red wire right, where is it? Is it the red one? Hold on, I'm losing track of what I'm doing here. No, my mistake. It's not a red wire, it's this white wire, I believe. This white wire right here, I believe, is the wire that should have 12 volts on it when the key is switched to the on position. So the ignition in the on position, this should go to very low resistance. Now it won't be as low as the 1 ohm because it'll actually be the entire resistance of the wire running all the way over to the key switch, through the key switch contacts themselves, and back over to this connector. So this wire actually goes down here, goes out the wiring harness, up to the key switch, through the key switch, back here, and then through this connector again, and then back up to there. So right now I've got deadly there. I'm going to go turn the key on, and I'm going to put my connector back on that, my multimeter back on the white wire, and bupkis. So that's not good. All right. You know, part of the problem is I'm going through by memory here. I might not have that right, that wiring right. Let's see. All right, so I'm going to pull that. Pulled this connector off again, and what I'm curious now is I'm curious to see which one of these pins here, which one of these pins on the boat side of the wiring harness with the key switch on has 0 resistance, or I should say very low resistance. Remember I said it's going to probably be not as low as the 1 ohm. So let's see, is it this one? No, there's nothing there. Looks like it's this one. Yeah, looks like it's probably that one. Just check these other ones real quick. Yeah, so it's this one right here. Whoop. And that's interesting. A second ago that was... I just tried that a second ago and it was much lower. So, see, I'm measuring 4.5 million ohms, way too high. While I'm at it, I'm going to check and see if that is in fact my white wire. So if I come over here on the motor side and I go to that corresponding pin and I go up to the white wire connection up there, you can see I've got almost just half an ohm, even less than half an ohm. So that is in fact it. So that's my ignition on. This pin right here should go to 12 volts when that ignition switch is turned on up front, and it's not, because I'm getting way too high. It's not going to, because I'm getting way too much resistance there. So I've got to find out what's going on here. So I'm going to go back to hooking up my so it's reading out of range or open circuit because I just shut the key off. So I'm definitely on the right wires, but I'm just getting way too high of a resistance. That's the key on again, and you can see it's all over the place. So I don't know if I've got a bad key switch or a bad connection in the wiring. Well, actually now I think it's just really heavily oxidized inside here and just needs to be really well cleaned. I got it just by scraping the inside of that hole with the end of the lead there. I got it to drop down to about 7 ohms. I'll just cycle the key on and off a couple times and see if it holds. I may have spoke too soon. That seemed awful erratic. Yeah, no, it could be the key switch itself. So the important thing is, at this point, is that the wiring is correct, which is good so far. So now the next thing I'm looking for is one of these wires should go high to positive 12 volts when the key switch is in the cranking position, and that 12 volt would go to the starter solenoid here and close the starter solenoid. So one or both of these wires that goes over to the starter solenoid. Let's see. So there are 2 pins apparently that correspond to, let's see, how's that working now? I don't remember how that starter solenoid circuit works. On some of these starter solenoids, the way it works is there's 12 volts going to the thing all the time. So in other words, this 12 volt input pin might be common to one of these. No. Or could be one, the negative pin could be common to one of these, and it is. So this is the side with the lower resistance. This side has higher resistance because that's going to be the side that is on the other side of the resistance of the solenoid itself. So the blue wire is going to be the one that needs to be connected to 12 volt when it's cranking, which is going to be, all right, it's going to be that topmost left top connector there. Well, there's 2 of them there. All right, so one of these goes to that. That's 4. Okay, there we go. So if I go back here, I go on here, when I go to the crank position on the switch, that resistance should drop way down. Only I can't see it when I'm cranking it, so I'm going to move my meter setup. All right, so when I turn this key switch to the crank position, I would like to see that resistance drop down, and I don't. But I might not be getting a good connection here. Maybe it's this. It might be this pin. Let's see. One of these 2 pins. 2 of the pins have to do with the crank circuit. Oh, son of a gun. I remember now. One's the neutral safety switch. It won't crank because I've got this in the forward gear position. In other words, right now it's doing exactly what it should be doing. This would not work because this is down and forward. This needs to be in neutral. Now, let's try that again. There we go. Again, resistance a little higher than what I'd like to see. But more importantly, it's working. It's the correct, the wiring is all correct. So, other than some high resistance problems, which, given the amount of corrosion I'm seeing on some of these connections, I'm not surprised. Theoretically, this thing, clean up the connections, put some new battery cables on this thing, and this thing might actually work the way it's supposed to work. Alright, so I gotta get some contact cleaner, and I gotta get another battery cable clamp, and I'm probably gonna see if I've got some battery cable or gauge wire that I can replace, because this is really bad cable. I don't want to replace the entire cable, but I think I can cut back to a point where I have good cable and splice in new cable and really improve the conductivity of that circuit. So the last thing I'm going to check before I go in for the evening, because it's almost supper time, is I picked up what I believe at the boat place to be the correct plug for adapting to my fuel system. So this has got that weird little connector, that quick connect here. It's got this little rod that sticks out, and when you hook up the connection, that rod's supposed to push in. That pushes in that little O-ring and opens up that circuit. And so this is what I picked up at the boat place, because the guy at the boat place told me this is what I'm looking for. And they had two versions. They had this Sierra one. This is an 18-8082. I think this was about 18 bucks. Comes with this connector, and then it comes with this brass adapter, okay? And that's all you got. And then from there, you're going to make the rest of your connection up, which I don't have a problem with doing that. And then the other one was quite a bit more. It was like $30, and I asked him why, and then when we looked at it, we saw, I think, that this part was brass, and he says that he's seen these get broken. This is some kind of like a white cast metal. I don't know if it's aluminum or not. I don't think so. So anyways, the moment of truth. That don't seem right. Okay, I see the pins. There are two pins to the side. They're horizontal. So this has to go in. You can see it. It's a bayonet style fitting, I believe they call it, because it's much like the way the bayonet goes on an old rifle. So you got to push this in and then click it a few degrees. Let's see, that would be as looking at it clockwise. Let's see. So in, up, and down, right? Oh, I see. They made this so that when it's on properly, these will be facing up, I believe. No. Not really. Horizontal, I think. Maybe about like that. Yeah. And then push in and click horizontal, and Bob's your uncle. That's it. That's the connection. And from this, we can do all kinds of magical things. We can go to a barbed fitting and a hose clamp and some hose or whatever, but we're going to eventually go to a primer bulb. And then remember last year I had a really hard time running this off of a gravity fed tank. I had a hard time really establishing fuel flow into the carburetors through those fuel pumps. But once I got it running, it ran perfectly. But then when I would run out of fuel, then I would have trouble getting it to restart again, or if after it sat for a while. And I think a big part of that is overcoming check valves in those fuel pumps. And I think that that problem is going to be completely mitigated once I hook this up to a primer bulb and a fuel tank. And the primer bulb, squeezing the primer bulb, will force fuel into those bowls on the carburetor, past those check valves. That's just the theory, but I thought I'd mention it. Alright, so I just tightened up this connection so I wouldn't forget about it, and then I remembered the reason why I didn't have this screwed all the way down was because this, when it's bolted to this position right here, sticks out a little bit proud of this edge right here, so it makes it a little bit hard to make that cover go on tight. So I think what I'm going to do is I'm going to grind off a little bit of this metal here that should still leave plenty of metal to make a good connection. And I want to do that because I think I had figured that that was easier than trying to get this to actually hook up down there and where that goes. That's a nightmare down there. Same thing with the bolt that holds this clamp on, that holds this in. Some of you may recall that that had become stripped out, so I had to tap that hole and put a new screw in there. So I don't really want to rely on that for this electrical connection, although I probably could get this cable to go down in there. But no, actually that's not going to clear that either. I think that's going to be in the way. So I'm going to use this hole, because this hole's here for a reason. So what I'm going to do is I'm going to take this off of here and take it down and just grind it. All right, so there's still plenty of meat there on this, and now when I bolt this on, it's flush with this edge here, so I'll be able to get the cover on probably with less of a struggle. Or maybe it won't make much difference, but I'll just feel better about it. And so that's it. That's all I'm going to do for today.